Hi, so in this video, I'm going to go through the code behind the breeding synthesis application. So the first class I'm going to look at is the noise generator MetaSound. So within this, you have a noise node, and the noise node is altered by a biquad filter, and then that sound is multiplied by an AD envelope. So an AD envelope is an attack decay envelope, and it has a linear attack and a linear decay. And within that, there has different parameters that can be altered. So for example, there's an attack time, which I discussed there, and a decay time. There's also an attack curve and a decay curve. So these values are defaulted at 1 for linear, but if it's greater than 1, then it will be exponential, and it's less than 1, it'll be logarithmic. With the biquad filter, you had the frequency, the bandwidth, and the type. And with that, this noise generator was then used within the Brett blueprint. And within the Brett blueprint, you have an inhalation noise generator and an exhalation noise generator. And in an inhalation noise generator, the type for the filter was initially set to a high pass, but it was too high, so set to a band pass. And even at that, one pole low pass filter had to be used to cut out the high frequencies. In exhalation, you used a low pass, and these then were added to a mono mixer. The exhalation also had a trigger delay as it starts after the inhalation. And then a lot of these inputs were the same from the noise generator. Then within the multipret, this uses the Brett node, and there's just a trigger repeat to play it multiple times. So there's a period of how many times it'll play. So as you can see, this is kind of object oriented. So you have your multi-Brett, your Brett, and then within the Brett you have your noise generator. So I like this type of coding style because I find it easier to visualize. So this is mainly the main setup for the MetaSounds. So then within that, then I'll look at the third person controller. So the first thing I'll look at is the event tick. So on event tick, this function is called calculate breeding parameters. And within calculate breeding parameters, you have a calculate stamina interpolation. So if you play the application, you would see a widget in the bottom left corner, and this represents the stamina of the player. So if the current stamina is 50 and the max stamina, which is 100, if they're divided by each other, then the stamina will become 0.5. And then in calculate breeding parameters, that stamina interpolation will be got and then put into get interp parameters. And in get interp parameters, you have a min and max values for different input values for the MetaSound. So this MetaSound is the multi-Brett, which I talked about. So for example, here we have the exhalation decay time. So there's a max exhalation decay time of 1 and a min of 0.5. So the idea is that with this system, depending on what the interpolation factor is, a value will be got between the min and max to satisfy that interpolation factor. So instead of storing a big long list of an array or a different data structure with all these values, you just store 2 or 3 values, or you just store 2 values, the min and the max, and this will calculate at a runtime. So this it's kind of hard to visualize it with the nodes. So a better example here is in the paper. So an interpolation factor is the current stamina divided by the max stamina, and the interpolated value is the min value plus the max value minus the min value times the interpolation factor. Now it's important to note that this code was attempted, and this is to get the exponential interpolation value, but unfortunately it wouldn't work when it would only work from the stamina going from 0 to 100, but wouldn't work when the stamina was depleting from 100 to 0. So when you get the interpolation parameters, you then pass them in and you set them in. And that's, for example, exhalation attack time and exhalation decay time. And these are all set on runtime when the event tick is called. So, so these inputs then are changed. So that's the main premise for how the meta sounds are changed. Now, just to discuss other parts of the application that are kind of relevant. So the main focus of this application is the breathing sound, but these different things were used to help showcase the procedural aspect. So there's different booleans that were picked. So these are all public. So is sprinting, is crouching, is jumping. And there's one here for is out of breath. So when the stamina is depleted, the is out of breath is set to true. And the player cannot run, jump, or crouch until the breathing is reset back to 100. In this, when to change the stamina, there's a drain stamina event, and to regen the stamina, there's a regen event. And basically, if you start running or crouching, it'll keep draining the stamina until it reaches 0. And if it reaches 0, it'll set it to out of breath, and you'll stop sprinting. Same with regen, but it's the opposite way around. So if you stop sprinting, then the value it'll go the other way. So it'll go up. So one of the things that I added to the application was crouch. So this is not in the third person controller. So you'll have to look at the paper to look at how to do this. But basically there is a crouch and uncrouch in the character movement. But just one thing that was different with the crouch, jump, and sprint is that when you're crouching, the stamina drainage is only set to 1. But if you're running, it's set to 5. And if you're jumping, that exerts a lot more effort, and that's 30. And then you have your sprint. And the sprint, yeah, it sets to 3. And so to look at the start sprint, in the start sprinting, so this event is called when you start draining. And in start sprint, there's a client play force feedback. And this client play force feedback will play the haptic feedback if you're playing on a controller. And if you stop sprinting, then it will stop playing the haptic feedback. There's also to note, there's interpolation negative and positive. So the difference between the two of these is that it's basically just going the opposite way. So with the volume, you don't want, with the volume, you want it to, you don't want it to, you kind of want it to go the other way. You want the volume to get louder. So the exhalation volume and the inhalation volume. And that's basically the main gist of the code. Just to explain further with the multi-breath, their attack and decay curve, these values are kind of altered, and I'm not really too sure if they're just right yet. So what was trying to be modeled was this attack and decay curve. So instead of kind of being linear, a breath is kind of more erratic. So you kind of have a logarithmic growth and then an exponential decay. Another interesting envelope I looked at, but I didn't get to develop, was a tongue envelope. And basically the idea is this would be more kind of like an ADSR envelope. I did have a look at this, but I wasn't too sure how to do it. And with that, you have the tongue envelope, and the tongue envelope would be multiplied by the breath envelope. Because one of the things that I found from testing was that people found that this breath sound, it sounded like the player's wearing a mask or something, or the character's wearing a mask. So I unintentionally had that happen, but if this sound is kind of to be developed more, that's something I would look at doing, is doing two types of envelopes. Maybe there's also other things that could potentially be added to this synthesizer. So that's kind of where I'd start first, is the ADSR envelope. Thanks very much for listening. I hope you enjoyed.